Hi guys, this is Mrs. Ringrose, and we are back at it again, building those skills to be able to write really good geometric proofs. So we're going to start with some algebraic proofs just to build those skills, because I know that all of you guys are comfortable with solving algebraic expressions and equations. So let's get started. These are some of the properties that you've already been introduced to with solving algebraic equations. But we're just going to make sure that we know all the names for them, because we have to justify every step that we take. And, we need to be able to say what it is that we did. So, for instance, the addition property looks like this. If I know that two things are equal, then if I add the same number to both of them, like, say, x plus 5 is also going to be equal to y plus 5. So think back to when you're solving equations. When you add something to both sides, then it's still going to be equal. Alright, so addition property, you can add the same thing to both sides. Subtraction property, similar. If x equals y, I can subtract the same thing from both sides, and it's still equal to each other. Alright, so addition property says I can add the same thing to both sides. Subtraction property says I can subtract the same thing to both sides. Multiplication property says that if two things are equal and I multiply both sides by the same number, then that equation is still going to be equal. And then division property, again, something that you used solving algebraic equations. If I have something like x equals y, and as long as I'm not dividing I can't divide by 0 still. However, I can divide both sides by a number, and it's still going to be equal. All right, substitution property is something that is super important when we're doing our geometric stuff, and that says that if I have some values that are equal to each other or expressions that are equal to each other, then I can substitute A in for B in any equation or expression. So, and we've been doing that too. Remember when we have to solve for x in an angle addition problem or a segment addition problem, and then we have to put x back into the expression to get the angle measure? It's just like that. So if I know that A equals 5, and then I have an expression that says 2A minus 7, I can go ahead, I can put that 5 in there, and I can figure out 2 times 5 minus 7. That's substitution property. And then lastly, we have the distributive property, which also I know that you guys are all very familiar with. And that says that if I have a number outside parentheses, maybe I've got like this inside, then what I can do is I can multiply that 3 on both those terms, and I get 3 times 2x plus 3 times 5. And I can simplify that a little further and get 6x plus 15. All right, so distributive property says that those two things are going to be equal. All right, feel free to rewatch this or pause it if you want to take the notes down, but I'm moving on. All right, so we're going to use all those reasons to justify what we're going to call an algebraic proof. So our statement in this case is an equation. I know that you guys all know how to solve this equation, but we're just going to justify all the steps. So the first thing that we're going to almost always write is original equation or given. And then the next thing that we got going on is that I want to move all the x's to one side. So let's move the x terms. And I can do that. You can do two different things. You can subtract 2x from both sides, or I can add 3x to both sides. We're going to add 3x to both sides. And I'm allowed to do that because of the addition property of equality. The addition property of equality says I can add something to both sides of the equation, and my equation is still true. So now these cancel out, and my next step is, forgot to add 5x plus 5 equals 20. And that's just simplifying. I combine like terms. All right, and then the next thing I want to do is move the constant term, and that's going to be the subtraction property of equality, because I'm going to minus 5 from both sides. And my equation is still equal. And I can simplify, and I get 5x equals 15. And then lastly, I'm going to use the division property. All right, so I'm going to need to divide both sides. So 5x divided by 5 will remain equal to 15 divided by 5 because of the division property. And if I simplify that, I get that x equals 3. All right, so that's an example of what we're going to be working on when I say algebraic proofs in class next time. All right. So I have one more example for you, I think. A literal equation, because it's everyone's favorite. Yep, so that's for when I see you next time. All right, so again, we are going to use our algebraic properties of equality to justify all the steps that we're taking in solving for h. When I have a literal equation, I like to just highlight somehow the variable that I'm actually solving for. And I have to know that I have to get rid of everything that's around the h. So in this instance, I'm trying to get rid of 1/2 and the b so that h is by itself. So again, I'm going to start by saying that this is my given, or my original equation. And first thing I want to do is get rid of the fraction. And I can wipe out a 1/2 by multiplying everything by 2. So 2 times a equals 2 times 1/2 times b times h. And I know I can do that because of the multiplication property of equality. And then I'm left with 2a equals bh, because 1/2 of 2 is 1, so it goes away. And then I need to get rid of the b. Why can't I write today? And to do that, I'm going to use the division property. Oh, I forgot to write down that I simplified. I knew that space looked empty. So 2a equals bh. And again, I'm trying to get rid of that b on the h. So I'm going to divide both sides by b, because that'll cancel out those b's. And I'm left with 2a over b equals h. Now, just a little preview for the next class. We want to actually sometimes have h on the other side. So sometimes we're going to flip things, and I can rewrite this. You know that an equation is equal on both sides. It doesn't matter what order we write it in. But there's actually another property for that, and you're going to have to know it. And it's called the symmetric. So a little preview for you, but we're definitely going to go over symmetric in class because that's something that I expect is going to be new for most of you. But there you go. In a nutshell, we are using the properties of equality that we know to prove algebraic proofs. And I hope this was helpful, and I'll see you in class.